We will solve this today's LeetCode problem. This is LeetCode easy one. So the question is intersection of two arrays 2. So let's see what the question is asking. So the question is given two integer array nums1 and nums2, return an array of the intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. Okay. So basically we have given two arrays and we need to find the common elements between these two arrays, right? And the numbers can be appeared as many times. So if it is present two times, it should be in it nums2 it also present two times, then we need to return two times the same element, right? The we need to find the common elements between the two arrays. The question just concluded that we need to find the common elements between between both the arrays, both the given arrays, right? Now just we need to find the common elements between both of the arrays, right? So basically if you see example 1, 1 to 2 1 and nums to 2 2, 2 2 is a common element, and here we have given the result in any order, so order doesn't matter. So we will remember this, that we can return the result in any order, right? We can return the result in any order. Return result in any order, right? Second, 495 and 94984. Although 4 is present two times in nums2, but we will take only one times because in nums1 there is only one times 4 occurring, right? So that's why the common elements between this nums1 and nums2 will be 4 and 9 only, right? So this is 9 and 4 also be accepted. So because order doesn't matter. So basically, if you see here, the first thing is first brute force approach would be, what would be the brute force approach? That what we need to do, that we will, or you can think of not a brute force approach, but it is a approach that we will check each an element, that which element is present how many times in this nums2, right? So basically what need to do, we need to store the count of we need to store the count of each element for each array, each given array, right? For each array, right? Basically we need to do that. And what I will do, i will just I will just check for each and every element, check for each and every element, either from either for nums1 or for nums2. But here you see that both of the length is different. So I will check that which of the length is smaller, right? I will check which of the length is smaller, and I can check, and I will see only that nums1 and nums2, that from these elements, from this much element is this count of element is present in my nums2 or not, right? Basically I will count all the each elements from each given array and check each and every element either from nums1 or nums2, that whether this element is present in my opposite array or not, right? And check, also check that uh, what I will check, that whether this element this element is present in my second array or not, and how many, if it is present then how many times, and if it is present then how many times it is present, right? Basically we need to just see that it's present, right? It's present. So basically for storing the count, we will need an extra array for that, or you can take a 1000 array, or you can take an unordered map. In both of the cases it will take O of n plus O of n, because the length O of n plus O of m, because O of n is the length of the nums1 array, and m is the length of nums1 length of nums1, and m is the length of nums2, right? So in both of the cases it takes length O of n and O of m minimum, right? And also I need to iterate. This is a space complexity, right? This is a space complexity. And also I need to iterate in whole nums1 and nums2 to count the num key for each element. So time will also take O of n plus O of m for that. And I'm also asking you to check for each and every element after accounting in second array, that whether it is present. So it can be possible that all the all the elements from in nums 1 and nums 2 are unique, right? So that will take O of n into m, for sure, for sure. O of n, definitely, right? O of n, right? Because I'm checking for each and every element, either from nums 1 or nums 2, depends on which is the minimum. So I will take for that, right? I will take for that, right? So basically, this can be done by brute force approach, right? This can be brute force approach. But how we will optimize this further? Can we optimize this further? Can we just can we optimize this space complexity or the time complexity? So if you see, observe here that we were we were we were using two we in our above approach we were using two arrays or two unordered map, right? Two arrays or or two hash maps, right? Two maps, right? Basically, to store the count of for each element, right? Do we need to use two arrays? Do we need to use two arrays? Let's see. If I take only one array, if I take only one array and count each any element from nums 1 and nums 2, because ultimately I need to find the common elements between them. So whichever length is smaller, I will store I will store. So basically, you can store any of the things. Either you can take nums 2 or nums 1. I'm taking the smaller one, because uh, it will take less space for me, right? Definitely. So I will take whichever length is smaller. I will store that in my hash map or array. You can take anything, right? So what will I do? I will Let's take this example, right? Let's take this sample. Or if I want to generalize it, you can also generalize it. So I'm taking this example. Suppose this nums2 is length is smaller. So what I will do, I will just count the number of elements. Suppose here it is also given 4 5 6, and again 4, right? And here it is given 5 5, again 5, again 5, right? So 2 is occurring two times, so 2 will count 1 two times. Again 4 is 4 two times, so again 4 count is 2. Again 5 count is 1. Again 6 count is 1 only. So I have stored all the elements present in this nums in my map. And what I will do, I will just go iterate in this nums and check whether this element is present in my map or not. I will just check that whether this one element is present in my map or not, without counting this. How we will do? Let's suppose I is 0. So I is referring to nums 1. So what I'm doing, I'm just using a single hash map to find the common elements. So what I will do, I will go to I0. I will check whether 1 is present in my hash map or not. No, it is not present, right? So we will not this will be not mean this will not be my answer, right? Basically, I will go to 2. I will check whether 2 is present. Yes, 2 is present. How many times? 2 times. But here we don't know the count of 2 yet, right? So I will just take this 2 in my answer and decrease the count of by one, right? Definitely. Again, I will go to at I is equals to 2. I will check that this 2 is again occurring, and we have R2 one times. So I will just take this 2 as my answer and decrease the count of this to 0. Now this one is this one occurs in there? No, it is not occurring. So this will not be an answer, right? So this 3 will not be an answer. So I will move to 4. This 4 is 5. We have 5, right? So this 5 will be included in my answer. Also, this leads to 0, right? Now again, when I move to 5, this 5 this 5 again occurs. We have 5, but don't have but we have a 5 the key 5 in my map, but its count is 0. It means there is only one, there is no left count of 5 in my nums2. It means this will not be in my answer, although this key is we have, but the count is not equals to this nums2 count, right? So this 5 will not included. Again I move to 6. Again this 5 and 5 is not, we don't have 5. So this is the final answer, 2 to 5. And if you see manually, this 2 2 and 5 and 2 to 5 is common only in my answer. So this answer is 2 to 5. So basically what I have done, I have just taken uses the single map for this instead of taking two maps. So basically space is now O of minimum of n comma n, right? Right. This is the space, and the time is only O of n and O of n plus O of n. And again I have don't need to again see check for each elements. I have just checked, I have counted one times, and I have again iterated again one times and find all the answers, right? So that's the answer of space and the time. So can we further, can we think of any other approach instead of this? So this approach is also acceptable. There is no doubt in that, right? This approach is acceptable. There is no doubt in that. If you don't consider this answer vector, if you don't consider this answer vector as a extra space, you can think of other approach also, right? What were the second, what was the approach? Let's see, right? Let's see. So you know how this can be implemented. This is very easy. If you want me to implement, let's implement just let's implement it, right? I will implement the second one using the single array, right? Using the single map or single array, right? So basically some nums to size. I will take another map and int map. Also what I will do, I will check whichever is whichever is minimum of the size. So basically for that what I will do, I will just check whichever is minimum. So how we will check that, right? How we will check that? So basically what I will do, I will check that if n is greater than m, if n is greater than m, so I will just iterate in nums2, right? Nums2, I will just iterate in nums2, right? Otherwise I need to iterate in nums1, right? That's for sure. That for sure, right? So we will use this, right? Either if n is greater than m, I will use nums2. Otherwise, I will use nums1. So what I will do, I will just count the elements in both of the cases, whichever is smaller. I have counts of elements of a particular array, of any array, right? So it depends on which array is used, right? And what I will do, I will just, so basically I can use a solve function here to do that, because I'm doing the same thing in both of this, right? Just the nums1 and nums2 is changing, right? So yeah, right. So that's what I am changing. So either you can use this, uh, or you can just use any of these elements like this auto it nums1, and you can just calculate, because it will not matter much. You can do that also, but this also doesn't matter much, right? You can also do that, and this also doesn't matter. So basically if you count the elements of nums1, you will move to nums2, nums2, and now you can just see that whether we have this count greater than 0 or not. Because if it is 0, if it is equals to 0 or less than 0, we don't have that count. If it is greater than 0, I will include in my answer, which is in my vector answer, right? So I will just include in my answer dot pushback it, right? Simply. Also I need to decrease this counter, right? Because we have taken this element from nums1 and nums2 both, so I need to decrease it from mpit, so that I will not take another elements of the same point. I need to maintain the counter also. So just right, I will return the answer, right? So just run this, this will be fine. This is just to just show you how we will implement this and submit it. Right? Let's see. Yeah, submit it. So how I do that? How I what I've done that I have just taken a nums one and then calculated for nums two. You can also take the minimum. You can also take the approach for the minimum one, like this n is smaller or m is smaller, and takes that space for m, but it will not matter much because there's the nums I and nums one is given only 1000, so it will not matter much. uh, so yeah, basically you can do that. But the another approach, which is the second approach, how we will just without using this space, how we will do that without using this, without using unordered map, how we will use that, how we will use that, right? How we will find, we will find. So one thing you see here, that we need to find the common elements, right? We need to find the common elements. So if I started, if I just see this is the same example, the same example. If I just short all the nums 1 and nums 2, so if I short it, this is 1 2 2 5 5 5. So how I click sorting? Because if you see here, the order doesn't matter here, order doesn't matter, so I can think of sorting, right? If the order doesn't matter, I can think of sorting, right? So I have sorted this nums 1 and also the nums 2, right? Also the nums 2, this is 5 and this is 6 after sorting. So if I short this, and what I will apply, I will check by each one. Sorry, I will check each element one by one with the second element, whether we have the elements equal or not. So if we check, but how we will iterate in this? So basically, what I'm doing, I will use two pointer approach, basic two pointer approach. I will use basic two pointer approach here. I will use a basic two pointer approach. If you have solved any of the question of two pointer approach, you can solve this now after sorting, right? Because this is a very easy problem. So what I will do, I will just take a two pointers I0 and J0 and check for each element one by one, whichever is, if it is equal, I will include in my answer, and if it is not, I will check which element is smaller, because we have already sorted it, so it is in given order. So if any element which is sorted, I will increment that one to make equals to that current element, right? So basically what I will do, I will just start iterating in I0 and J0. So 1 and 2 is equal, no it is not equal. So but one is smaller, right? One is smaller. So if one is smaller, I will what which index which index will move? One is smaller, so I will move I element, so I will equals to 1, right? I will equals to 1, right? Again, I is equals to 1 and 2 is still 0, but 1 is not equals to 0, right? And 1 is also smaller than 2, so I need to again move 1 to 2, so again I will move to 2. Now this 2 and this 2 is equal, it means we have some common elements, so 2 will be included in my answer. Also I need to move this to 3 and J to 1, right? So if I do this, so what I have done, I have, if the numbers are equal, if the numbers are equal, if the numbers are equal, I will take that. Also, if I have taken that current element at current index, I need to iterate, I need to increase the counter, increase the index of both of the nums array, because I have already taken it. So I need to check for further elements, so I will increase both of the index, right? So this 2 3 and this 2 1, this is again similar, so I will include this in my answer. Again this is the same, so I will increase both of the pointers, so this is will be 4 and this is again 2, right? Now this 4 and 5, is it equal? No, it is not equal. But which element should be, which index should be increased? So this 4 is less than this 5. So if nums 2 j, nums 1 I is greater than nums 2 j, nums 2 j, jth pointer will be increment, because 4 is smaller than 5. So I, if I don't move jth pointer further, how will I know that whether we have 5 or not, right? So we need to increase the jth pointer to 3 and ith will be remain same. So at 4 and 3, this is the same condition. 4 is less than 5, so I will increment 5 again. Now this 5 and this 5 is similar. It means I can take that. Also, I need to move both of the pointer. This becomes 6 and this will be 4, right? Now this 5 and this 6 is not equal, right? This is not equal. So this 5 and this 5 is less than this 6, so I need to move this to 7. Now if you see, we have go out of the bound condition for nums 1, right? So basically if I go out of the bound with nums conditions, so I don't have any common elements now, so that would be the my answer finally, right? That will be the my answer finally. So if any of the array elements go out of the bound conditions, we don't have any we don't need to check further, because that would be only the that we will not get any common elements between them if any of the array go out of the bound condition, basically, right? So this is how we will use two pointer approach after sorting to find it. So basically if you see here, we have sorted it and only used two pointer to find the common elements, right? If you don't consider this answer as a space, so basically we are not using anything except this two pointer approach, right? So if you don't consider, so time will be o of n log n plus o of m log m. Although we have taken we have this time greater than this, because this is greater than this, right? So but we have reduced the space to o of 1 if you don't consider this answer as an extra space, right? If you consider this, so that will be the minimum of n comma m, right? That would be the minimum of n comma m. If you don't consider this, uh, if you don't consider this answer, right, then this will be o of 1, otherwise it will be o of m into m. And also here the space would be extra spaces, that would be the map space, that can go to uh, o of the max of n comma n, or you can write it like o of m min of n comma n. It totally depends on you, right? So this is how we will solve this problem using two pointer approach. So let's just write this. So instead of using map, what I will do, I will just use a two pointer approach, but after sorting, right? So I need to sort it. Sorry, nums dot begin, nums dot and in Java, I also there is also short function. You can sort that again, but that will take. Uh, sorry, this will be nums or not. That will take I think o of n for sorting it in Java, but in C++ it will take o of 1, and I think in worst case o of log n, as per I know. And the space complexity I'm talking about, right? And the time complexity will be o of n log in both of the cases in Java and C++ both. So basically I need to take I0 and J0 while I j. So I should be less than n, and also j should be less than n, right? Because we need to find the common elements. If any of the arrays go out of bound, I will leave that. Right? So what I will check whether this I is equals to enums to j. If it is equal, I will take it as my answer. That comes one I. Also, what I will do, I will just increment. See, I will just increment this cases, right? This is the same cases. So I will just increment both of the pointers. Else if nums1 I is greater than nums2 j, what I will increment j at pointer, and otherwise I will just increment I at pointer if nums1 I is less than nums2 j. Right? So this is how we will solve this problem, and let's just run this. And something, okay, I have not declared vector. Now this will work fine. Let's run this. Something is missing. Okay, I have nums2 dot end, right? Because we need to sort the whole array, not only the first element, right? Yeah, we have passed the cases. Let's submit it. Successfully passed, right? So if you see the analyze time complexity, it will give n log n m log n. That's the same, and we can also see the memory o of minimum of n comma m, because due to this is due to the answer, and that previously it was due to o of 1, right? So let's just click it. So this is the new feature by LeetCode. You can see that. So thank you so much. Hope you liked it. Bye bye.